Hello everyone, welcome to Twinstock. I have two huge printers here with me. As you can see, they don't even fit in here with me in the middle. So on the right side I have the Elegoo which I got from Kickstarters, and on the left side I have the Anycubic Photon M3 Max, which I bought from Amazon. I'm going to compare these two and we'll see which one is going to be my new favorite printer. So stay tuned, find out more here at Twinstock. So let's start unboxing this together. As you can see, the Elegoo comes in this cardboard box, a really stiff one. I don't know how it looks like beneath there, and we're going to check the Elegoo first. And then I'm going to switch over to the Anycubic, which also came in a cardboard box, but I already removed that, and as you can see, it's protected by a metal frame, so it does not get damaged during shipment. But I'm going to put this aside and I'm going to start with the Elegoo and we're going to see what's in the box. This thing is heavy. How am I going to get this out? I have to damage the packaging. I don't like that, but hey, it's okay. So, I need a break. Just a second. Back from my break. So, actually, it looks really great. I will get off these foils and so on. This looks so nice. I really like the black. It's so nice. Oh, let's see. So, first, there's no damage on the printer from shipment. It looks good from the finish. There was a protection on the display here, which I removed. And let's see what we have inside. Oh yeah. Okay. So, let's see. First of all, you may have already seen all these unboxings, so I'm going to only mention this briefly. We have the filters. No, that's the FEP film. Prep release film, yeah. It's FEP film. Then we have this toolbox. Nice. So I'm not going to talk all about this. You may have seen other unboxings. There is this filter here, some stuff, the caps for the bottles for the automated refill system. We're going to talk about that later on. And yeah, That's the, let's see. Why? Yeah, now. Let's see. How do I get this out? Without damaging anything. Okay. And the plate. Okay, and that's the build plate. So yeah, it's really huge. It has a nice finish. This was sandblasted. Great. And then we have screws. Oh, look okay. Nice. Let's see. I'm going to get all this stuff on the side. We don't need this yet. And this one. And let's see. This is somehow reminding me of the 3D Systems Fab Pro 1000, which I reviewed. It was also this huge, but it had a tiny build platform, and this thing is huge. It's great. I like it. So the linear rails we have here looks like 20-25 millimeters or so. I don't know, I have to check that. And we have a really nice ball bearing here. The platform here is really stiff. There's nothing moving at all. So I may have to connect the cables first and then get the platform up. And yeah, let's do that. So before I start putting this thing up, I'm going to show you around the printer. We have some ports to connect to, and on the right side, when you're in front of the printer, there is this USB port here. And then you have the power jack and the power switch and the networking port, two handles on the side to carry this thing. On the back, there's nothing. On the other side, left side then, there's also no ports to connect to. There is one port I did see, which is inside, actually. And it's an USB port for connecting the filtering system. I'm going to power this up. And actually, you can see here, maybe, I hope so, that the linear rails and the ball screw is greased really well. There's it's really shiny, and you have much grease on there. That's great. It should be like that. So let's start the printer and get the platform up. I have to get this up my fingers. Okay. Let's see. Tools. Let's get this up. The display is really responsive. That's really nice. Manual, and get it up 10 millimeters. Let's do 50. 1, 2, 3, 4, 5. I can hear the ball screw, or maybe it's the stepper motor. It's not that loud, but I can hear it. And there's also a fan which is running. Okay, let's see. Get this out here. Yay! And to get the wet out here, you can just unscrew it. It's the same system as before, but the screws are thicker. And there's also a leveling cord and instructions in there. get this one out slowly, and that's the card. Strange. Oh yeah, here it is. That's the leveling card, and this is a huge vat. There is a film on there. We have to peel it out later on, and here's the connection for the cap of the bottle. So I will show you this later on, because these have automated refill systems where the resin is flowing into the vat automatically. You also have some kind of a automated refill system on the Anycubic, and I'm going to compare these two later on. So what we also have in here is a second film. We have to peel that off, I think, yes. And there is no protective screen saver, how you say that? No protection film on the display. I will have to get one for that, because if you have a bad fab and the material flows onto the display, it's most likely will damage it. Okay, let's look at the accuracy. I got to get my dowel, and we're going to see how accurate this X is moving. I just mounted my dial indicator on there, and we're going to touch the platform and see how much backlash we have. Let's see, just go up 1 millimeter and millimeter again. Okay, it's at 0, and I'm going to increase by 1 millimeter. So I'm going up with the platform, and I'm going up again 1 millimeter, so it's 0. I'm going back now 1 millimeter, and we have a backlash of 0.07 millimeters. I will check with Elegoo if this is within the tolerance of this printer, and maybe somehow this can be adjusted. They can do this in firmware. We talked about this with the Anycubic printer, but I will also call the support and check with them if this is alright for the printer. Yeah, let's get this out and dial indicator out, and then I will check the noise level of this, because I can hear the fan on this side. So I've got my sound level meter here, and we're going to check the fan and the noise here. It seems that it's on the bottom of the printer. I will try to go around and then just tell you how much I got on the sound level meter. Let's see. On the side where the power switch is, we have 64 dB. On the back we have 71 dB. On this side we have 64 dB. Let's check from the front. There we have 70 dB. So this printer is not as quiet as the old Elegoo ones. At this point I would look at the UV light source, but I don't have any safety glasses, and the specs for this printer and the UV source are really high, so I will skip that and go over to the Anycubic now and see how the rails are and how the ball screws are, etc. So let's check the Anycubic Photon M3 Max. So here's the Anycubic, and I'm just going to get a Allen wrench key and get this thing off, and yeah, let's see what's inside. I just removed all the packaging, and it seems that I have to assemble some of the parts. We have the covers here, and they have some screw holes here. I have to screw these on, I think. Then there is this cap piece for putting it into the bottle and other stuff. So I'm going to just screw this thing together and check if it's working. I think there's something in this card box here. Maybe. There's an instruction manual. Okay, I will check the instruction manual first and then see if I can assemble this. And also there's a screen protector in here which we don't have on the Elegoo Jupiter. So I like that, to have a screen protector shipped with the printer. So I'm going to assemble this and we're going to check if this printer works. So guys, I'm having some trouble getting in some screws at the back of the printer, and I have to recut the M3 screw holes and see if it will fit down. So let's see. I just finished assembling the printer and I had some problems with the M3 screws and the holes. I had to recut some, but now everything is working. There are some little bags which have some more screws in them, but I don't know where to put these in. There's nothing in the instructions manual. So I think these are just spare parts. If you have to maybe open up and screw up some screws, you can use these as replacements. There's the Vat here. There's the Vat in here. It's lighter than the one we have from the Elegoo. We will compare these side by side later on. And this is the build platform. It has a different finish on there. Maybe you can see this. It's sandblasted, and after that it has some kind of a laser structure. It's like a chest plate. Looks great. Nice finish. And then we have this screen protector here and some other stuff in here. Some accessories, some filters and so on. And then we have this part here. Actually, this is for the bottle. You screw this into the bottle and it's pumping in the air from this part. And there's also some kind of a plug here. You can check, I think the printer is checking if there's any material in the bottle left. It's just checking the resistance between these two metal pieces. So yeah, we're going to check the parts of the printer next, and I will just show you around. If we look at the Anycubic, it does have a different cover. You can just pull it off like this, and then you can put it on like so. Sometimes it just, yeah, a little bit difficult to put on, but that's okay. Going around the printer, we have the touch screen here. Then we have a USB port on the side, the power switch and the power jack, where you just plug in the power supply, and at the back you have the holder for the bottle. There's some connector here for this piece here. Actually, these are the pipes coming out from the automatic refill system. You just put them on here, and this is also, I think, the printer is measuring the resistance between these two aluminum pieces. And if there is not enough material in or resin in the bottle, it will just stop the print, or so I think so. Going around further, there's nothing on this side. So let's just get the power supply and connect this, and then we'll see how accurate the axes are. I just connected the power supply and we'll power this on. Let's see. That's the first time. It's stating Anycubic Photon. Okay. Okay, so we have print, system, and tools. Let's check tools. Okay, it's also responsive, really responsive. So let's check tools, and then we're going to move the Z axis. Let's see, 1 millimeter, this one, and then we're going to go up first. Okay, let's go 10 millimeters. Okay, first thing I have to mention here is that the stepper motor is actually starting slow and going up faster and faster and then slowing down again. So it has a slope for acceleration and deceleration. And it's different than the Elegoo. The Elegoo just starts with mostly full power. And I think this is a little bit noisier, but you don't have any fan running here. So this is completely silent right now. Okay, so we're going to go up a little bit more. Okay, get the cover off. Now we are going to measure the backlash, but let's check the rails. And as you can see here, they have the same issue as they had before for the other Anycubic. These are not greased at all. I mean, okay, I can see a little bit of grease on the ball screw. I can see a little bit. But there's nothing on the rails. It's completely dry. Anycubic, why are you doing this? Just put on some grease. Down here there's a little bit, but that's not enough. Okay. So I have to put on some myself later on. Okay, so let's get the dial out and then we are going to measure the backlash. I just measured the dial on this printer and we're going to go up and see how much backlash we have. So 1 millimeter up. Okay, so get this to 0. I hope you can see this. That'll be 0. So going up 1 millimeter. Do you see that? It did go 2. I don't know why. But that's okay. So it's at 0 and we're going down 1 millimeter. Let's see. Not working? Why? Okay, up. Strange behavior here. As you can see, it's going up and down 2 millimeters. Maybe it's the screen protector we have on there. So, yeah, get the film off. Let's see. 1 millimeter, and we're going down again first. Okay, it's working better now. Okay, let's go up 1 millimeter. Okay, let's keep this 0. Okay, we're at 0 again. First 1 millimeter up. It's at 0. Again, 1 millimeter up. It's at 0. So I'm going down 1 millimeter. And it's at 0.02. I'm going up again, 1 millimeter. It's at 0. I'm going down. It's at 0.025. So I will go up 2 millimeters and then I will go down 2 millimeters. 1, 2. It's at 0. I'm going down 2 millimeters to see if it just sums up. 0.03. Okay. 0.03. Okay, so we have a backlash of 0.02 to 0.03 millimeters. That's half the backlash we have on the Elegoo. So I think with this you can work with. This is much better than what we had on the Elegoo. So I get this off, and then we're going to look at the other stuff we have on this printer. As we did with the Elegoo Jupiter, I'm going to measure the noise level with this sound level meter on this Anycubic Photon M3 Max. But as you can hear nothing because no fan is running. And I can put this thing everywhere. It's just at the sound level which we have in this office. So there's no increase in sound level. I think that the fan is off till we start a print, because you have to cool down the UV light source when printing. So I will measure the sound levels later on in a second review where I will look into the print quality and other stuff. I have the printers side by side now, and as you can see they are very different in size. The Elegoo is around 73 centimeters in height, whereas the Anycubic is at 60 centimeters. Also the length and width of both of these machines are different. If we look at the weight, we have to say that the Elegoo is much heavier. It's around 40 kilograms, and the Anycubic is half of that at 20 kilograms. These are actually the case, I think, which is much heavier and more robust than what we have here with these plastic covers. I will open up both cases, and we're going to measure the linear rails width and the ball screw diameter. As you can see, there is a base connected to the linear rails, which the platform will be screwed onto later on. And if there is too much weight from the print we have, these may have a deflection. And I will going to check this deflection too with my dial. So let's see. So the Anycubic, let's see if I can just measure that from this side, has 50 millimeters for the linear rails, and the screw is at 16 millimeters, where on the other side the Anycubic has 20 millimeters for the linear rails. Let's see if I can get in here. And 12 millimeters for the ball screw. Yes. So the ball screw on the Elegoo is much thicker as for the Anycubic, but the Anycubic has thicker linear rails. I'm going to measure the deflection of this space, and we're going to see how much this will bend when there is a force applied. Okay, so I'm going to push on here. Oh, the axis just fell. So we can only do that if the machine is on. So let's turn on the machine. We're at 0. I'm going to put pressure or apply a force on this base at this length. We're just going to measure that. So we have the same length. So from the start of the linear rail, it's around 14 centimeters. Let's see. Putting pressure on. It's at 0.03 back to 0.01, 0.03. So it's at around 0.02 deflection. Let's push, but this wouldn't be needed. But we have a deflection of 0.04 millimeters here. Let's see what we have on the Elegoo. I'm going to measure the 14 millimeters from the linear rail. And then I'm going to power up the machine so the stepper motors have power. Okay, should be okay. Let's see. I have to say, I like that display from the Elegoo much more. It's much crisper than the image what you have on the Anycubic. Let's go up. And then down. So we're at 0. I'm going to push. Oh, yeah, it's at minus 0.08. And it's not going back. It's staying at that minus 0.08. And then I'm pulling it up. Let's see. It's at 0.05 plus. And I can wiggle this around. You see this? It's around 0.16 millimeters. And I can see actually how the rails are going up and down the slides on the rails. There is some play in the screw here on the back, and I will have to check with Elegoo what's the problem here. If you look really close, the complete assembly here from the ball screw down to this coupler is moving up and down within this block. I don't know if you can see this, but it's just going up and down. And I think this was also the problem when we measured the backlash. So I'm going to check this with Elegoo, and there's much play in here. Let's look at the platforms for these. This one is from Elegoo, and this one is from Anycubic. And as you can see, they are different in design, whereas we have aluminum parts on the top here which are machined. We have some extruded parts from aluminum in a special design, which they most likely cut in pieces in that width and then machine for this groove here. On the let's look on the platforms, and I don't know if you can see this, maybe it's not like this. They are both sanded and they are both nice in finish, and as you can see, the Anycubic one is around let's say 2 centimeters higher, and the width is around 1 centimeter more. So a direct comparison here of these build plates, you can see, so like this, you can see that the Anycubic has a bigger platform to print on. This is also stated in the data sheets, where we have a different size for the parts. For the Anycubic we have 298 millimeters to 164 millimeters, and you can go 300 millimeters in height, whereas we have a build volume of 277 millimeters and 156 millimeters to 300 millimeters in height. So there is around 2 centimeters on one side and 1 centimeter on the other, which you can print more on the Anycubic. It's smaller and has a bigger build volume. Let's look at the vats. This is the vat from Anycubic, and as you can see, you can mount the bottle on here with the bottle cap, so it has an automatic refill system. I'm going to talk about that later on. And it's heavy, but really nice build quality. And this is the one from Anycubic, and I think this is around half as heavy as this one. Yes, and looks like this. So I'm going to check the material which we can get in here, and the max level, it's stated on here, it's the max level of material you can get in this vat from Anycubic is lower, much lower than the max level you can get into this vat from Elegoo. But all in all, they both look really well made, and yeah, we're going to check how much material we can get in there later on. So let's check the automated refill system for the Elegoo. This is actually a really easy way of refilling the vat. You have these caps which you screw on to your bottle, and this one is then pushed in here, where we just open up a valve which goes in there by the spring and open up the way for the material to flow from this groove into the vat. There is an issue which could happen on this kind of refill system, that if you have a bottle, let's take this one, the caps may not fit, so you may have to print yourself an adapter. And also another issue is that if the bottle you screw on is not tight, airtight on this screw here, then this vat will fill over with the complete material which is in the bottle. So it will not feed automatically, but if air gets into the bottle, the whole bottle will fill the vat. So the complete material will be drained. On the other side, if we look at the Anycubic, it's a different system, which I personally like much more. You have these sensors in here, and if the vat fills up to a certain point, let's put this up. If it fills up to a certain point here, these contacts will the resistance of these contacts will change and the pump will stop. So there's a air pump here which you connect to the bottle with a special cap, this one, and this also only works with one type of bottle. So if you have a different kind of bottle like I have, like this won't connect. So you may have to print yourself an adapter for this. You connect one end to the piece where it just filling up the bottle with air, and the other one is going back from this here through this pipe and coming up here where it just fills up the vat. If the connection is made here, it will just stop. If the material is used up, the resistance will change within these two pins here, and it will start pumping up air into the bottle again and having it push material through this piece here into the vat here. The same issue we will have if the bottle is not tight. If it's not tight, the air which will flow into the bottle will come up from the screwed part here. So you have to have it really airtight. Okay? I like this much more because you cannot overfill the vat with the system. Only if there is an electric problem, the pump will start and overfill everything. The other thing what I like is that you have the bottle outside of the printer. So even if the printer is printing, you can just change the material on the back side here. Whereas what we have to do is, during the print, we have to open up the case for the Elegoo and then reach into the printer, get the bottle out, and get the bottle, new full bottle back in. You can stop the print during that, but most likely you will see a layer shift. Yeah, so I like the refill system of the Anycubic much more. I will show you something else which I was working on before Elegoo and the other companies came up with this system. I've built my own automated refill system and it just looks like this. You can upgrade all of your resin printers with this and have it refill your vat. What you have here is the connection. This is a colder cap, and this is the bottle you have the resin in. And what you do is just you put this on here and screw it in, and that's it. So the material you have in the bottle will flow into the peristaltic pump, but will not go into the vat. So when the peristaltic pump starts, it will flow out from this pipe and fill your vat. I have made this and I tested it, and I couldn't finish it because all the other companies came up with their own solutions. But just so you know how this works, I was using different kind of sensors, like this one. It's a ER sensor, and also I've been using time of flight sensors within a pipe where there is a small how you say that, a small ball in there which will float when the material gets higher. So what I could do with this was that I could also check the volume, or how you say, the level of the vat, how much material is left in there. So you just connect this, or you just put this into the vat like so, and then you connect the cable up to your Arduino or anything else, and then connect it to my refill system here with the peristaltic pump. And if the vat volume or if the vat level goes behind the below a threshold, which you just measure here from this time of flight sensor, it will start to pump till the threshold is again increased over the threshold, and then it will just stop. The nice thing about this is actually you can have the peristaltic pump go backwards and completely empty your vat without having to use these grooves to spill it over into your bottle. But I didn't finish this. It just worked, and seeing that the other companies have been using their own solutions, I may not come up with my own. But you can state something into the comments. Maybe I will just get starting on this again. So let's sum this all up. As you can see, the Elegoo Jupiter is actually a much bigger and heavier machine. The build quality is also higher than what we have here on the Anycubic Photon M3 Max. The Photon M3 Max has a bigger build volume than the Elegoo, and the accuracy is actually better on this one than for the Elegoo Jupiter. The Elegoo Jupiter has some kind of a problem with the ball screw, and there's some play in there, so I'm going to contact support and see if we can get this thing working. And the Anycubic is just good as it is. The only thing is we don't have any grease on the rails and on the ball screw, but all in all it looks nice. It's much easier to lift, and for now I would say the Anycubic just wins this race between the two because it just doesn't have the flow of the ball screw. But I will get both of these machines running, and we're going to do some test prints and see how the refill system works on both of these, and also compare the build quality. So stay tuned and find out more in the next episode about these two printers, and see you soon. Bye.